Hey everybody, welcome back for some more intermediate motor controls. We are going to be discussing today automatic input devices. Now so far we have talked about manual input devices. Okay, this is simply the push buttons that open and close, they break and make contact and also allow or disrupt the signal to our output device. So we are going to now talk about automatic input devices, ones that don't require human intervention to actuate, okay? There are two types that we're going to talk about. The first one is the mechanical type. This basically uses a set of contacts to switch state in our rung of logic to either turn it on or turn it off, okay? Contacts just like you see in your push buttons that you're used to working with so far, okay? The contacts close and allows the voltage to pass through, or if they're normally open, if we press the actuator, it opens those contacts and it disrupts the flow of voltage going to or throughout the rest of our rung and on down to our output device. So we have the mechanical type. We also have the sensors that we're going to talk about as well. Now these don't use contacts like we're used to seeing in switches and also the mechanical devices like I just talked about. These use solid state circuitry in order to pass the voltage on further down the line. Now we still use them in the control circuit, but they don't use the hard contacts that you're used to seeing in switches and other devices we've worked with so far in this class. But we're going to talk about both of these. And both of them are used to detect certain conditions on a machine and to control output devices accordingly. Okay, in essence, what we're going to do with automatic input devices is, for example, let's suppose that in order for our machine to go into automatic, all hydraulic cylinders had to be retracted. Well, in order for our relay logic to be satisfied and to go into automatic, we would have, for example, a limit switch in the fully retracted position. So when the cylinder's ram comes back, it actuates some type of input device and it says, hey, I'm fully retracted. And suppose we have to have them all in the retracted position. Our system would need to know that, so it would take information from each one of the automatic input devices to say, hey, all the cylinders are retracted, I can now go into automatic. It's sort of a simplistic example, but that's one of the, when we're talking about automatic control and sequencing and things like that, we'll use those sensor or these automatic input devices for that function. Again, it allows for the automatic operation rather than, again, using hydraulic cylinders. If a cylinder were to stroke forward, extend all the way out, you don't want to have a guy run over there and say, okay, it's all the way out, I'm going to push a button. No, we have devices that will sense the position of that cylinder automatically for us and do a lot of work and leave the human intervention out altogether. Okay, but that's how it works. The first type we're going to talk about again is the mechanical, and again, like I said, it uses a set of contacts to make and break. Okay, the first one we're going to talk about is the limit switch. This is going to be the first type of mechanical input device that we're going to talk about. It's the limit switch, and then we're going to talk about the level and the float switch, and then we're going to talk about pressure switches. Okay, let's start with the limit switch. First of all, this is an Allen Bradley 802T. Okay, very common, used throughout industry. I've seen hundreds of these. Okay, basically this is the body of it right here. This is your actuating head right here, and this shaft right here has some type of actuator. I've got a real one here to show you. This is a Siemens a 3S model, and this is, I mean, they're very, very similar. This is the Siemens, that's Allen Bradley, very similar in design and the way they work. Okay, this is your actuator. So if let's say my hand is a hydraulic cylinder, when I'm fully extended, I'm going to hit that roller right there, and you can hear that clicking. That clicking is the contacts making and breaking inside our switch. Okay, so whenever my hydraulic cylinder hits the limit switch right there, we could say that's fully extended, and it will turn the directional valve off to quit trying to shove it forward, to extend it. But this is fairly straightforward. You got a little hole down here for a 1/2 inch seal tight or conduit. And you run your wires, you park your wires right here. And just showing you, I'm not trying to, you're not going to get a whole lot out of this, but you land your wires right here, your hot wire, and then you have your wires coming in and out of your contacts. And these are little prongs, they're like plugs right here. It's real easy. If part of the switch gets damaged, you don't have to replace the entire switch. These are, they're really, they're pretty good switches. You can take the heads and turn them 90 degrees or 180 degrees, which, like for example, if your part is coming this way, well, it's not going to actuate the switch, so all you got to do is take the head, flip it 90 degrees, and then the actuator will sit like this rather than remount the entire switch. So you can configure it a lot of different ways, but they all work fairly the same way, okay? You got different kinds of contacts in them too. This is the symbol for a limit switch. You'll see this in your relay logic, okay, on your rungs of logic. This is a normally closed, held open switch. This is a switch in the open position right here. Sometimes you'll have limit switches with more than one set of contacts in it. This one here has two. It's really quite common. And again, you know the mechanical linkage right here means that these two sets of contacts are connected, so that when a force comes and hits this actuator right here, it will close it and it will take this one and open it. So you'll be able to switch states of your switches. Okay. So here's a little GIF I've got for you. This is just kind of reinforcing what we've talked about so far. You got a force actuating the lever there that turns the shaft and limit switch. Again, we've got a hot wire that goes in here. And what we're trying to do is pass the voltage from this hot wire through the switch on down to our load that's somewhere else in our circuit. Okay, so whenever the actuator is back, the power will go through the normally closed set of contacts, through the black wire out the red wire, okay, and fire that output device. When we actuate it, it flip-flops just like you've done before in the lab. Okay, it flip-flops. The neutral is, the hot wire is then interrupted. And the normally open set of contacts closes, and we have an output device or output signal coming out of the switch there. Just a little GIF there to show you kind of how that works. Okay. Now, the nice thing about these switches, they're rather simple. They're really robust. I've seen them, a lot of them smashed up pretty good, but they're easy to replace, easy to wire in. They do a great job. They're fantastic in harsh conditions, whether it's corrosive, where you got a lot of dust, a lot of grease, grime. I've been in some plants where there's just a tremendous amount of animal fat, things like that. And they're just covered in these. The switches are just covered in this animal fat material and all this stuff. Just keep on working. They're great. They're almost bulletproof. Okay. One thing they won't hold up to is a fork truck, but they're almost bulletproof. And again, you got different types of actuators. This is the roller type. This is kind of showed you close. It's got a little roller, okay? Just lets it roll right across my finger there and like that, and it makes that switch all day long, okay? And again, this tightens up against the shaft here. The shaft is usually splined, so is the hole, the receiving hole in the actuator, so that you can get a good tight grip, because after a lot of cycles, it would want to slip. If it was just a smooth finish, it would want to try to slip. But they got splines on there to kind of grip tight, and then you got to tighten up your the clamp, the gripping pressure right there with that screw. Okay. This is an example of a limit switch here. This is a little a cam with a lobe on it, and as the cam could be connected to the shaft of a motor, and as that motor rotates, okay, the cam will come over here and hit the limit switch. And when it breaks the contacts, it could be the contacts that tells a motor starter, hey, stop running the motor. So they'll be in the full travel position of that motor. But again, this cam will kind of rotate, hit that, and it will cause those contacts to make or break. This is sort of like the example I showed you. You got a part that runs across the limit switch and will make it and break it. Okay. This one right here is typically, that's a typical application for your garage door openers. If those of you who may have automatic garage door openers, you have a motor in there with a cam wheel right here with a lobe on it, and when it travels to the full up position, this lobe will come around and hit a limit switch and shut the motor off to keep it from continuing to retract and tear everything up. The same thing on the opposite side. There'll be another cam wheel with a lobe on it, so that as the motor continues to drive the door down, you set it to where it hits that actuator right when it sets on the ground. You make a little adjustment on your shaft so it can go one way or the other, and just really fine tune and dial it in as to when it makes and breaks those contacts, so we don't damage our garage door. But this mechanism here, the limit switch, is up there in the garage door opener itself, very, very small. They're not this size here, but they still make and break a set of contacts just like these limit switches here do. Okay. The actuators, again, this is just one type, the one with the roller on there. They got a bunch of different types of actuators, too many to go into. This is one I picked up because I've worked with these before. These have long reach, okay, so if you got a limit switch mounted here and you got a part coming out over here, you know, fairly good distance here, you can have that switch and reach whatever, because again, that actuator I showed you earlier, it was about, you know, 1.5 inches or so from the shaft. This one will reach much further. Also, this has a spring down here on the end of it that flexes, so that so there's something that really makes it travel. There's only so much travel you can get out of this turn here, and it'll bottom out. This right here, if you have to have something continue to travel, it will flex and not continue to put pressure on this switch beyond its limit. So it's got just a different type of actuator. Okay, the places that you typically will see them used. Again, if there's a part or a component present, if the hydraulic cylinder is extended, something like that. Safety gates, you'll find a lot of limit switches on robotic cells or robot cells. If there's a safety gate on there that has a limit switch, it's designed to shut the operation down, the robotics operation down, if someone were to open that door and try to get in with it in automatic. Okay, so it keeps them safe. So there's a limit switch so that when the door opens, the limit switch will make a set of contact or break it, depending on how it's wired. Okay, and it will shut that down just like that. Again, we've already talked about the cylinders having these, on there to determine if they are fully extended or fully retracted. Okay, I personally used some on landing gear on aircraft when I was working on aircraft years ago. We had the landing the gear up, full up and full down. Okay, let the pilot know it's safe to go ahead and put it on the ground. Use limit switches to detect the position of the landing gear and the actuator. Again, actually the switches were on the actuator as well that drove the gear up and down. So a lot of different applications, but and too many to go into for this lecture. But here's something very important. And while we're talking about symbols, I'll talk to you about this for a second. A lot of you are struggling right now to identify some of the most basic symbols in these schematics. Now, folks, this stuff's not getting any easier. I've told you that from the very beginning of 1401, okay? And I think I've been true to my word on this. It's not getting any easier, okay? It's going to get more and more complex. We're going to build and build. But the one thing you've got to do is you've got to learn your symbols, okay? So that's all I'm going to say about that right now. But these are the symbols for the limit switch. You got a couple of different configurations, okay? Number one, you got the normally open, held closed. Basically, you can look at it like this. All right, so my hand is the whatever object's going to actuate that limit switch. Okay, it comes up and hits that little actuator, and this is normally open. It's just kind of hanging open. It's normally open, and when I press my whatever it is that actuates the cylinder, it's going to press that set of contacts closed, so it's going to hold them closed. So this is a normally open, held closed. The only way it's going to be closed is if we hold it closed, okay, in the actuated position. So it's normally open, held closed, okay? Okay? That's the same switch, it's just one is open, or excuse me, one's being not actuated and the other one's being held closed from the actuation. All right, on the flip side, you've got the normally closed, whereas if we have our switch just holding it there, nothing's hitting the actuator, nothing hit that little roller bar, okay, it's going to be in the normally closed position. Now we open that switch when whatever force, whatever mechanical force that we talked about earlier, whatever force hits this actuator right here, it will take it from this state here, the closed state, and upset it and open up that set of contacts. So this is the normally closed, held open. So get your head around those two symbols right there, okay? So we've talked about the switch and the contacts. Where do we put it into context? Well, this is a very simple control logic circuit, okay, relay logic circuit. And this is the symbol. Now we just talked about this particular type of symbol. This is a normally open, held, closed switch, okay? This one right here. So we have some type of an actuator, something comes up and bumps our limit switch, okay? Whatever it is in our process, and it hits that, and we turn on a solenoid valve, okay? So and then whenever the force moves away from the limit, physically moves off of the limit switch, that set of contacts opens back up, and we kill our solenoid, all right? Let's take a look at one more thing here before we move into our other schematic. One thing you got to be real careful about is the contact rating of our contacts inside the switch, okay? Now, number one, these switches never, ever, ever have three-phase voltage passing through them, okay? Some of you are still struggling a little bit between power circuit and control circuit. You will never have these in a three-phase motor circuit. Now, you may have these in light residential or maybe in light commercial motor circuits, okay, where they actually turn the motor on and off, and those contacts will be rated for those small motors. But we're talking about industrial three-phase induction motors. You will not see those in a power circuit. You'll see them in the control circuit, but not in the power circuit. Okay, so as I told you earlier, it can have two sets of contacts. Well, in this Allen Bradley 802T, we have two sets of contacts. We have the normally open, held, closed, mechanically linked to the normally closed, held, open. Okay, so if we wanted to wire this switch up, if I handed you that Allen Bradley switch and said, here, go wire this up, okay, what you're going to do is you're going to take the hot wire. Okay, I don't have the number designation, but let's say this is 1. And we know that this would be 3 because our neutral's 2, so we got 1 and 3. And we're going into a limit switch, and we want to use the normally open, held, closed contacts. Okay? Well, what we're going to do is we're going to take our hot wire, our number 1 wire, and we're actually going to put it on terminal number 1. Okay? And then when it actuates, that power is going to come out on terminal number 2, and we will have our number 3 wire hooked to that. So the contact between, or the passing of voltage from the hot wire over to 3 comes through this set of contacts on these terminals, okay? So again, we're going to wire this up here and close it and close our solenoid, okay? Let's talk about this for just a second, all right? So here is, we're going to go back in some hydraulic classes. We're going to kind of cross over in some other disciplines here as we talk about our limit switches. Here we've got a control circuit that we're going to hit the start button, and as long as our normally closed, held open limit switch is closed, okay, we're going to hit our control relay, we're going to energize it, we're going to control this set of contacts right over here, and that's going to energize our directional control valve solenoid, okay? And for our hydraulic unit, we've got a pump here running, it's running right now, we've got pressure going up to our valve, okay, and when we energize that solenoid, it's going to shift that valve, okay, and we're going to deliver fluid to the back side of our cylinder. It's going to extend it. When we take it off, the spring is going to push the solenoid this way, and the spring inside the cylinder is going to try to retract the cylinder and push all the fluid back. So let's kind of pull these all together, all right? And one other thing too, the most important part. The limit switch is out here so that when our cylinder strokes all the way and extends, we hit that limit switch, okay? When we hit that limit switch, it's going to affect the state of these contacts in our control relay, okay? So this is the physical switch, and these are the contacts that are in our schematic, okay? So let's go ahead. We're going to hit the start button right there. We've done that. We've closed our set of contacts, and now our directional control valve has been energized. We shifted the valve, and we started porting fluid to the back of our cylinder, piston in our cylinder, excuse me. And then we're going to continue to, as long as we have not hit this limit switch, we're going to continue to push fluid and make it force that cylinder out. We've stroked it out here, and now we have hit our limit switch, okay? And in doing so, we have opened up our limit switch contacts, okay? So, and as soon as we open up the limit switch contacts, our control relay is de-energized. We have the normally open contacts return to the normally open state, and then our directional control valve solenoid is de-energized. Our valve shifts, fluid is now porting back. We're also coming off of this switch too, so this will return to the normally closed state. I don't have it showing returning back that state, but once this comes off of here, I guess when it's extended, it opens it up, and when it retracts, it's going to close. It's going to allow these switches to go back to their normally closed state. Real simplistic example, but it'll kind of give you an idea of how that would work in a hydraulic system. Okay, that's what we're talking about, our automatic operations. You know, I'm not out here hitting a limit switch. We're letting the cylinder stroke for us and run the machine automatically. The only one thing I do have to do is hit the start button. It's not the best example in the world, but you kind of get the principle behind it. All right. One thing you do want to pay attention to is the voltage and the amperage rating of our contacts. If you look back here, right here on this Allen Bradley switch, you have got the control voltage that's permissible across these contacts and the amount of current that can that the contacts can handle as well, okay? And again, I can't emphasize enough, they're only used in the control circuit in an industrial setting or with industrial equipment, okay? So again, this is your, going back to that cam switch with our garage door opener, we've got the limit switch here. We're going to run forward. We can call this up, and the reverse could be down. So we're going to drive our garage door up until we hit that top limit switch. Once we do, we're going to shut our motor off in that direction. We decide we want to put the garage door down. We push the reverse button. It starts driving that motor down, okay, and driving the door down, and it'll continue to do so until it gets to the bottom, and there should be a limit switch set very close to that so it opens up just in time so it does not crunch the door down into the concrete. But that's what your limit switches are used for. Those are a couple of limit switches that are in your homes, okay? So anyway, that is the general part of the limit switches. You know, just again, make sure you understand the symbols, how they work. You'll get to work with some of them in the lab. You're going to be working with them on the troubleshooting trainer that we have built, the panel that we've built. So again, this is part one of 3 parts. I'm going to go ahead and start. I'm going to go ahead and stop right here and let you just kind of absorb what we talked about. And then come on back for part 2, because we're going to be talking about sensors. So if you've got any questions about this, be sure to find me in the lab. I'd be glad to work with you. Thanks a lot.